Hello everyone. In this video we will be looking at circular tracks. Okay. So what happens here is, let's take two cases. So here you have a circular track. There's a starting point. A and B are moving in opposite direction. So let us say A speed is 15 meters per second and B speed is 6 meters per second. And in another case, let us say A and B are moving in the same direction, same speeds, 15 meters per second, and B is moving at 6 meters per second. So now let the length of the track in both the cases we assume as let's say 189 meters. Just for the sake of calculation convenience, we will take something like that, 189 meters length of the track. So now if you are finding out the meeting positions or time taken to meet between A and B in both the cases. In the first case, they are moving in opposite direction, so the relative speed would be the sum of their speeds. So 6 plus 15, so that's 21 meters per second. Hence time taken would be 189 by 21, so that will be 9 seconds. In that time, the distance B has covered would be 9 times 6, so that's 54. And distance A has covered would be 9 times 15, so that is 135. So clearly, as you can see, they add up to 189 meters, right? Now let's say they meet somewhere here. Okay. Now with this as a starting point, what will happen is, with this as starting point, again the movement will happen. So the second meeting will happen as if this is a new starting point, and again they will meet. Relative speed will be 21 meters per second, time taken would be 9 seconds, the distance B will cover will be another 54 meters somewhere here, and this will keep on happening for different periods of time until they again come back and meet at the starting point, after which the cycle is going to repeat all over again. Now this kind of to track the entire movement looks kind of difficult. So what we will do is a slightly different approach. So let us see what we are doing. Since they are moving in opposite direction, their speeds are going to be added. But what is the ratio of the speeds? So let us take ratio of the speeds. So ratio would be 15:6. So that will cancel with 3. So it will be 5:2. Now if I divide this circle in 5 plus 2, 7 parts. Why did I add? Because the relative speed is in the opposite direction, we add, right? So in the same way, here also we add the speeds, the ratio of the speeds, we get 7. So let us divide this circle in 7 parts and see what happens. So roughly speaking, this is 1, 2, 3, 4, 5, 6 and 7. So 1, 2, 3, 4, 5, 6, 7 parts we have divided. Now this is where A is and this is where B is. Just as that we are not going to work with 15 and 6 anymore, we will look at 5 and 2. So this is 5 and this is 2. Now let's look at the first meeting point. Okay, A is going to cover 5 parts, 1, 2, 3, 4, 5. B is going to cover 2 parts. So A covered 5 parts, 1, 2, 3, 4, 5. B covered 1, 2. This is the first meeting point. Now to just check, we had got that the distance B should cover is 54. Now is that correct or not? So if this is divided in 7 parts, each part would be 189 divided by 7. So 189 divided by 7 would be 27. This is 2 parts, so this would be 54 meters. So that is matching. So now if I continue this, now see what happens. This is the first meeting point. Then B would continue going in the same direction. So B will cover 2 units and A will cover 5 more units, and you will reach here. See, A will go 1, 2, 3, 4, 5. So this is the second meeting point. And if I do this, now it's very easy to find out the exact sequence and exact positions of the meeting. Third meeting would be here, 2 units for B. Fourth meeting would be here. Fifth meeting would go there. Every time I am just counting 2 units for B, right? Because B is basically 2, A is 5. Fifth, this is 6th meeting, and then the 7th meeting. As we have discussed that they are eventually going to come back to the starting point. So here they are at the starting point, and from here on the exact cycle will repeat. So this will be the 8th meeting, this will be the 9th meeting, the 10th meeting and so on till the 14th meeting, and it goes on. So if I want to find out how long it takes for the first meeting, so we have already figured that out. Now if I want to know how long it takes for them to reach the starting point, so time to reach the starting point, since this is the 7th such meeting and each meeting takes 9 seconds, it would be 9 times 7, 63. Now this can be done in another way. How do we do this? So what is the time taken for A to reach the starting point? For A to reach the starting point would be the length of the track 189 by 15, and time taken by B to reach the starting point would be the same 189, but this time B speed is 6. Okay. So if I cancel this, reduce this, so this would be 63 over 5 and this would be 63 over 2 seconds. Now observe what we are saying. A reaches the starting point every 63 by 5 seconds, B reaches the starting point after every 63 by 2 seconds. When will they both reach the starting point? That will be the LCM of these two, 63 by 5 and 63 by 2. As you should be knowing that LCM of fractions is LCM of the numerators, so which is 63 by HCF of the denominators, which is 1. So it would have taken 63 seconds to reach the starting point, which is basically the same thing as we had got here. Now if I want to repeat this entire calculation for this case, so what should we get? Let's quickly do it. The speed ratio 15:6, this is 5:2. Since it's the same direction, we are going to split it into 5 minus 2, 3 parts. Okay, this is for the same direction case. Now A is going at 5 and B is going at 2. So for the first meeting it would be 1, 2, this is meeting 1, then 1, 2, this is meeting 2, and finally this will be meeting 3. And this pattern will keep on repeating over and over and over. What is the time taken for the meeting? So time taken for the first meeting would be the length of the track 189 divided by the relative speed, which is 9, so that would be 21 seconds. And time taken for the third meeting, which is at the starting point, that is 21, 3 such meetings, so 63 seconds. Now that is, see, consistent with what we have got here. Because for the starting point meeting, we are not really looking at relative speed, but we are basically looking at the LCM of the time taken for them to meet. So the LCM should have remained the same irrespective of which direction they are moving. So that actually comes out to be true. So to put this in short, what we have in circular tracks, so I'll just give you the relations. Opposite direction movement, speed of A this way and speed of B this way, then find out the ratio. Let us say it is A:B, then divide the in A part and trace the points, the meetings. If your movements are in the same direction, then again you will find the ratio. Assuming A is the higher value, then you divide the circle in A minus B parts and then trace the meetings, okay, and you will be able to solve. If you are looking from a formula perspective, so number 1, first meeting will be the length of track by the relative speed, and number 2, meeting first time at the starting point, that would be the LCM of their individual times. So length of speed of A, length of speed of B. If I call this small t and if I call this capital T, point number 3, number of meeting points, that would be T divided by small t, and this will be the same as what we are getting as A plus B or we are getting as A minus B. So this is essentially what is circular tracks is all about. I hope this was clear. Thanks for watching.